Let's start out by talking about what we did yesterday, just to remind you. We went through and we discovered that a different way to search than you were used to was to make a sample that looked like the one you wanted, close enough that it would be a match, and then write a loop that goes through and tries to find the one that matches. And so there's the sample one coming in, there's the loop running, and that function that we called equals is actually, does this thing match? Okay, so you give it another thing that looks like the one you want, and they get to talk to each other and decide whether or not they're close enough to being a match. If you go look at the equals method in Motor, whenever you see an equals method, think of it as, is this similar to or close enough or looks like, right? And so reading this whole thing, anytime I see the word serial number in here, I just view it as, oh, if these two things that I give you have the same serial number, I guess they're the same thing. They're close enough to be a match that I'm going to think of them as being the same. Okay? That's all that that stuff means.
Why did you put it as object one instead of motor one? Is it just because you want to be able to use this anywhere, or is it already?
The reason for object here is because officially you're allowed to match against things, in this case, that aren't motors. So you can match a motor against a cat, and officially the answer is return false, they're not a match. And so there's a way of checking to see if the thing that came in was actually a motor. But we're not going to do that, because what will happen here is if you send a cat in and say, does this motor match a cat? When you hit this line, it's going to die, because it's going to try to take a cat and try to say you can talk to it like a motor, and the answer is that's just totally unintelligible. And we actually want our programs to die in that case, because if you do find yourself comparing a cat to a motor, it's probably something really silly than compared to something that you would normally want to do. So you should really only be comparing one motor to another motor to see if they match.
Well, okay. The cat is the motor.
It's never going to be. We're going to put the same sort of, we're going to always try to compare the same things against each other. So this is basically saying, I know that thing coming in has got to be a motor, so put it in a motor variable.
So do we have to like try and catch it?
You don't have to do anything with it. You're just going to let it die and it'll be fine. And so the bottom line of this thing is that any equals method that you write more or less always follows almost exactly the same pattern. It has to have exactly that signature, otherwise it's not going to override the existing one. You're always going to do a line that says this sort of thing. If it's student, it'll be converted, put it into a student variable, and then you're going to have a piece of code that tries to decide whether or not it matches based on values that are inside the object. And the other key thing about this is that you notice that we don't match against, say for instance, current hours on the motor, because current hours on the motor is something that's going to change, and if you matched against current motor hours on the motor, you're saying I'm only going to consider these motors to be the same if they have exactly the same serial number and exactly the same amount of time on them, which is generally not what you care about. So you only use values in there that are some pieces of the information that you're keeping, and the pieces that you check against are invariably only the pieces that are permanent and aren't going to change for the life of the program. Okay, any other questions about equals? Okay, and like I say, we're going to write more of them right away. We're going to, after we get this one done, we'll write another class, start all over again. Okay, back to the driver for a second. In the driver, we said there's a way where we could make a sample one and then write a loop to go through and see whether or not the sample matched one of the ones that was already on the list, and then print out a message if we found one. The shortcut for that is that it turns out that ArrayList already has that functionality built into it on purpose, because most of the time you're searching for lists of things. And so all motors is an ArrayList, right? It was declared at the top as an ArrayList. And ArrayList has a built-in search for function, which unfortunately is not called search for. Right? So this is actually search for a matching one, which is what index of does. So index of basically does exactly that same loop, And notice that in that loop, it specifically calls equals. So in order for index of to work and do its job, your motor class had better include an equals that says these are the reasons why things match. If you don't include an equals method of your own, you get the default matching, which is that it has to be identical, which is normally not what you want. Because if it was identical, you'd already have the one in hand and there would no reason to go searching for it. Okay? So now instead of writing this code, it just becomes easier to say, let's go do search for this way. Okay? Guaranteed to be without bugs. They tested it. It works. If it's there, it gives you back the position on the list of where it is. So it says, I found that item at number 5, the real one. And then at that point, you can go and retrieve the real one off the list. So you talk to the list again and say, go get me that thing that you told me where it was. You can update it, and that automatically still keeps it on the list, and it's now updated. So we haven't removed it from the list. We've just gotten a value for it and updated it. Still sits on the list. Okay? Questions about that? Okay? So that's a Boolean thing. Either it matches or it doesn't, and either we find it or we don't. Then we moved on to the next idea, was that we'd actually like to be able to put things in order. Instead, we'd like to weigh them and say which one's bigger or smaller, which one's better than the other one. Okay? And so for that, we said we'll choose to compare two things to decide which is better. So that's the word we used for that. And comparison always involves subtraction, because subtraction gives you the difference between two things as a magnitude. So in this case, I'm comparing their number of hours, and the one that has the least number of hours is the order that I want to put things on. I want to put them from smallest to largest. Okay? So I always think of, when I'm doing this an example, I always think of people's weights, because that's the most obvious one. So that idea, I weigh 205 pounds, you weigh 150. The difference between our weights tells me how much bigger I am than you. If it's a positive number, it gives the sense of I'm bigger. And if I subtract my weight from your weight and end up with a smaller number, it means you're bigger than me. And so we're always going to stick to that idea of my current hours minus your current thing, and that will always order things from smallest to largest. Okay? And that'll be our default ordering for things. Okay? So that's just a simple subtraction. Just out of interest's sake, what if I wanted to order motors on the basis of their serial number in alphabetical order? How would I do that? It's not a number, it's a string instead. Serial number is a string, so you can't subtract strings directly. Instead of subtraction, we would change this to serial number, which is my serial number, type the dot, and it turns out that string already has a compareTo function available for your use. And so it's that string compared to other dot get serial number. I did that right with a semicolon at the end of the line. Okay, so this is string compared to some other string, and string already has the ability built into it to say this string is bigger or better than another string. So how would you decide if one string is better than another? How do you think strings compareTo works? If you were trying to put two people in alphabetical order, you've got Albert versus Fred, what do you do to put them in alphabetical order? Let's choose the first letter out of each string first, and if letter position for A, number 1, is less than letter position for Fred, number 6 or whatever it is, right, then 1 comes before 6. So really it's just the numerical position of the characters in the alphabet that determine whether they're larger or smaller. Okay? So it still generates a number, which is the difference in letter positions between them, and that's what's used, still comes back as a number that you can use to do the comparison. So the rule is going to be really simple. If somebody gives you an integer that's what you want to do your comparison on, you take the difference for integers. If somebody gives you a string, string has a built-in compareTo that will do the work for you. You let strings compareTo give you the number instead.
So is strings compareTo, it obviously, like, it's built in, so it doesn't care about case?
Strings compareTo is very, very, very smart because it needs to know about uppercase versus lowercase. It needs to know about the mooks and the max, the order that they're supposed to come in, whatever that happens to be. I think in the old days they came before everybody else and now they're integrated in. I can't remember. Whatever the correct thing is, it does. And it's even smart enough to do different languages. So it just automatically knows that Swedish ordering is this, and so if you have your locale set to Swedish, it just magically does whatever Swedish alphabetizing is, and you don't need to know. Okay? So it turns out that it's very, very smart, which is why you use it, and it just returns, it says this string is bigger or less than that string. Done. Some people get confused by this because they see compareTo here and another compareTo immediately below. They're two different things. This compareTo belongs to the class up top, so this compareTo belongs to the motor class, versus this compareTo, the thing that there for that variable is a string. Okay, so since serial number is a string, that's strings compareTo. So just like every object can have an equals to say, do I match another object that looks like me, they can also have a compareTo to say, how do I place myself in order compared to another object. Okay, so either one works. I guess I should change that back the way it was, maybe. Just we'll leave it as an integer for now. Okay, so we'll put it back to we want the least used motor. That brings up another question. How many equals or compareTo methods do you think you can have? Huh? Unfortunately, no. Just one. Okay, so you can only ever write one equals because that's what the one is that you're trying to override. You can only ever write compareTo because you can only compare yourself to another motor. How do I decide, you ask? You decide based on, for the primary one, on the type of problem that you have. So for motors, it makes sense that the way we're going to identify them as being unique is by serial number and certainly not by hours. So that just becomes the default that everybody's going to use. For compareTo, it turns out that it's more likely for that one that you're going to want multiple ways of putting things in order. So I want it in alphabetical order. Sometimes if I want a list by serial number, I want it in numerical order by current hours. Other times if I want to go find out which motor should I service next. So it turns out that we're going to have one that's the sort of the normal way that you would do it, which is the way you mostly do it in the problem, and then we'll find a way of doing alternate comparisons pretty quickly that'll use a totally different mechanism other than this one.
Why didn't you use override for compareTo?
I guess I should, but not yet. Actually, the difference is that it turns out that there isn't a default compareTo, and so there's nothing to override.
So you made compareTo.
So compareTo isn't built in.
Okay.
But that point is going to come up pretty quickly in another way. Okay, so we've got the compareTo in it. We went and we used the compareTo ourselves directly to see whether or not we could take two motors and compare them. It turns out that most of the time you don't care about using them directly because there's already built-in facilities that will show you the stuff that you need to know anyway. Okay? So most of the time the reason you write compareTo is that so somebody else can use it, which in this case is something like go find me the smallest one. Okay? So now we get to how do I search a list and find the smallest one. The way that you do that is by saying it's a utility library called collections, and inside of it there's min for minimum, and you give it the list to search, which in this case is all motors. So that says go find me the smallest, and the smallest one is going to come back to you as the smallest motor. Like that. Okay, so there's the multiple bunch of motors. Collections.min is go find me the smallest. Since it's asking a question, I'm going to put that into a variable to hold the result, and the thing that I'm getting back has to be a motor, so I can then have a variable that talks to it in motor type ways. Notice there's still the red underline underneath min. And the error message in typical compiler fashion is blah de blah de blah de blah, blah de blah de blah de blah. Makes almost no sense at all. Okay? The key thing here of all of that is this one little line underneath, that one little word that you can see right at the bottom right-hand corner that says comparable. Okay? That word comparable there is very important. We'll go back to the motor class. You asked the question about equals versus compareTo. I said the override here was to say that one's built in. The problem with this one is that you actually can't just write it. You also have to announce that it's there. Okay? And basically this is a standard way of comparing things, and you have to wave your hands at the top of the file. Big wave, wave, wave. Hey, there's stuff in here that will do the comparing for you. And the way that you do that is you add this function, this name, implements, if I can spell it correctly, comparable for only motors, like that. That thing is like putting a sign on the front door that says Spanish spoken here. It's telling people something about what to expect inside. They can say words that are going to make sense that wouldn't normally make sense otherwise. And so all that thing does is it's an announcement that somewhere in the file you'll see a compareTo. And it's an announcement that says, hey, you can put these things in some order. So you have to do two things in this case. You have to both write the function that does the ordering, and you have to put the announcement at the top of the file to say that it's available. Okay? If you don't do the announcement, notice that you can still use it, which is what I did there, because I just basically walked into the door and said, I'm assuming that Spanish is going to be spoken here, just let me give it a try. Okay? But some things like collections.min are smart enough to go, I'm not even going to go look and try unless there's a sign on the door that says this is possible. Okay? So in that case, notice that the error message has now gone away because it now knows I made the announcement, I waved my hand, it says, hey, I got a compareTo in there, you can use it, go ahead, sort away. Okay? And now it's happy. Okay? So notice now the error message goes away, and then we can do something like print the smallest. And I guess I should put some message there. Like so. Okay? And now if we run it, it'll hopefully go find the smallest unless it died. Oh, it died. This was my junk piece of code here. Oh, it died on there. This was the one where a motor was, we'd made it null way back when. At some point, I think. Oh yeah, let's take out that line. Did I show you guys this yesterday? Yeah, okay. So I made motor null, so the reason for that null pointer exception was when I went to use the motor variable, there was nothing in it to talk to. So I just put it back to there's something in there, which will make our lives a little easier. Run it again, and there's the smallest one with 0 hours, whatever it happens to be. If you change min to max, it will find the largest one instead, which is that one, so I'll change that to say largest. So there's min and max. Okay, so the bottom line now becomes in your class, if you, when you write this one of class like we've been writing, if you go into it and you write an equals method, then you get, then whoever uses your class gets searching for free. And if you write a compareTo method, then they get sorting for free because there's already libraries to do that. Okay? So now the burden on people who write these lowest level things is to make sure that you have that stuff in there because it makes your class more useful for doing a whole bunch of things.
Those blue arrows next to equals compareTo in the toString, is that indicating that they do hook into other functions within Java, or
I don't know. I don't look at every single icon, so I don't happen to know.
Okay.
But while we're at it, we'll put add override on this one, if I spell it correctly. And at override here actually works in the sense of saying, I'm planning on overriding the thing that I said I was writing there. So if this thing was a promise to write a compareTo, if you accidentally don't, it'll warn you. Okay, so it's another one that is just a good sense of saying, I'm overriding a standard one, even though technically speaking there isn't one there already. Okay, notice also that if you don't write this thing, let me just comment it out. So there's add block comment, by the way, in case you've never seen it before. You can select a bunch of text and you can just say add block comment and it'll comment it out for you, which is sometimes really useful. If I don't write that thing in there, then notice that it will give me an error at the top of the file here, and it actually tells you. It says, hey, your implements comparable promised that you were going to write a compareTo, but there's no compareTo in this file, so there's a mismatch here. You didn't fulfill your promise. And notice it's at least there kind enough to say, there's what you need to write. You need to have compareTo against another motor because that's what your promise said. Okay, so it basically works in either direction. Okay, let's do one last thing here. Instead of doing minimum and maximum, our other opportunity is to do collections.sort and give it all motors, the whole bunch of them, to sort. And sort says, rearrange the list to put them in order. Okay? So the thing that used to be at 0 is not necessarily at 0 anymore. It's going to basically scramble the list from its original order, from the order that they came in, to put them into a sorted order. And now if we go through the entire list with a for each, a motor in all motors, change it to some other word because a motor is already used. We'll print out this motor, make use of the toString because I'm lazy. And I guess I should print a message here. We'll just say sorted order. Put it in quotes. Save it. Run it. And there's the sorted order with the 0 and the 65. Could add more motors to try it out to do more things. What if you wanted them in reverse order? Highest to lowest, which sort of makes more sense. I want the most used ones because those are the ones I'm most likely to want to go repair. Only last one that you're going to need from the collections library. There's collections dot reverse. And if you say collections.reverse and run it after you've sorted them, it flips the entire list around in the reverse order, and then they come out from highest to lowest. So as a general rule, you're always going to want in your comparison routine to do my stuff compared to the other guy, always get the order to come out smallest to largest, and then if for some reason you want it in reverse order, you call reverse afterwards to flip them around. And so that keeps us consistent. We're always ordering by default from lowest to highest. People know that, and they just get used to using that. If you do the comparison in the compareTo the other way around, and you do other guy compared to me, then you will get them in showing up from highest to lowest. But the problem with that is that it messes up min and max. Because the way min and max work is they just take the thing that's the leftmost for the minimum and the rightmost for the maximum. So if you've arranged your list in reverse order and you say, give me the minimum one, it's on the left-hand side, and you get the what looks like the highest one. So it ends up being sort of confusing. Okay? So if you always keep the list lowest to highest, then min and max work exactly the way you'd expect. Okay? Questions about that? All of a sudden we're getting a whole bunch of stuff for free because the libraries basically got those routines built into them. If you can do that much stuff with a list of things, this is probably 60% of the coding that you ever do is taking things and putting them onto lists, grouping them together, updating one off of a list, maybe firing the list out to a database essentially, getting the list back, doing stuff with it. You're basically always updating it, you're always searching for things, and you're always putting things in order.
So if you wanted to sort by hours, you would just change your compareTo method to compare hours instead? Current hours?
Yeah.
That's all you have to do?
Well, it's current hours right now rather than alphabetical.
Oh,
I changed it back from alphabetical, but yeah.
Okay.
But yeah, you would make the change. But right now you only get, when you write the compareTo, you always write yourself, for this application, what's the most common way that I'm going to use it? Just the one way that's always the most common way. And then we'll find if we get some special ways that we want to do it on occasion, we'll find a different mechanism for doing that. Right now, just one. Next example, more of them. Okay, well, how often do you think that compareTo is being called? Once, twice? Let's just dump a few more things onto the list. Let's just do motor, some other motor. There's a new motor. And we'll add some number in there, and we'll add another one. We'll give this one some hours. And before I put them on the list, just as a convenient shortcut, I'm going to add some hours to them just because that's what we're sort of interested in seeing. So I'll add some hours to that one, and HH will add some hours to that one, however many it happens to be. 5, just that we've got a bunch of different motors in there. They're organized in different order. Just make sure that error goes away. There we go. Okay, so I've now got a bunch of motors on the list. I run it just to see what happens. Oops.
You want to add them to the list?
Yeah, now I have to add them to the list. All motors.add. So dump them onto the list, and we'll dump the other one on. So there's a couple of more motors on the list to play with, and now if we run it, there's a whole bunch of motors arranged from highest to lowest. Okay, so that did some sorting. Well, if we want to see how often it's called, let's just go into the motor class, and in the compareTo, I'm just going to put a print line here, and I'll do the simplest thing that I can do for a debugging statement, which is to just say compareTo called. And we'll run it again. Oops, where is it? Oh, look at there, there it is. So there's when we were trying to find the largest, compareTo got called a couple of times. And then when we tried to find, do the sorting afterwards, compareTo got called a whole whack more times. Okay? And it turns out that for every one you add, it actually starts to go a lot higher. So maybe we'll just add one more motor. We'll give it 0 hours, what the heck. And we'll add in JJ and run it again. Oops. Thanks. Do that, add it to the list. Save it. Run it. And if we go back up and look here, there's compareTo called a whole whack of times. Okay? So the more you get on there, if I did 1,000 of them, there would be almost n squared of compareTo showing up. Actually something less than that, but it's more or less, think of it as being lots and lots and lots and lots. Okay? You can get a little fancier with the compareTo if you want. You can print the two things that are being compared. So that keyword this means the current object. So that's really this dot toString. Dump out the toString for the current object, and I'm going to compare it against the other guy, and the other guy is other, and that's other.toString again to do the work. And so I'll put in a little word there just so we can see it, and then we'll run it. And this will even show you the pairs of things that are in use. And so if we go back up and look at the compareTo, you can try to see it starts out by comparing BB and AA on the list, then it compares GG and BB, so it's basically trying to find the biggest one or whatever as it's going along, and it's called a whole bunch of times. Okay? So if you want to see it in a printout, there's just the idea that it's being used a whole whack of times. Now, it turns out that equals and compareTo, particularly compareTo, because they're used so much, they want to make them absolutely as efficient as possible. Okay? And so we'll start with the compareTo first here. Notice there's this call to get current hours to ask the other guy, hey, how many hours do you have so that I can do the comparison? Okay? Special rule in Java, just for this efficiency, it turns out that calling that function can be expensive, and they're trying to make it absolutely as efficient as possible. So there's what I call the professional courtesy rule here, which says that for objects that are the same thing, this is another motor, I don't actually have to ask them for stuff. I can go reach across their desk and grab stuff from them, and instead of calling the get, I can actually get at the other dot current hours variable directly. And it's strictly for efficiency purposes. It eliminates the overhead of a function call for just being able, you don't have to ask anymore, you can just grab. Okay? So the rude way of thinking about this, because this is practically the only semi-dirty joke I get to tell in class, is that the way to think of it is objects of the same type can look at each other's private parts. Okay? So even though it's officially marked as being private up at the top, if you happen to be the same type of thing, you can just go grab that stuff directly. Professional courtesy, you're a policeman, I'm a policeman, you got paperwork on your desk, you know that since we're operating on the same rules, I'm not going to mess with you, let me just go look at your paperwork and grab some stuff from it. Okay? So that's the special rule for that, which means that in the motor class now, every time in those two functions where you see that we've called the getter, you can just replace that with serial number, so we don't even need to say this thing anymore in the equals other serial number. We can just use other dot serial number, which is the variable. Okay, so it shortens all of those calls up a little bit, so basically done the same thing with both of those now. Okay, and it'll still work. Java won't complain, so that's breaking the privacy rule on purpose. It's one of the few times that Java actually does that. Okay. So I'm just going to go back and comment out this print statement because it was just debugging and I don't want to see it anymore. It's also one of the few times you'll see me use a debugging print statement just because that gives a sense better seeing the output rather than stopping on the debugger every time and wondering how many there are. That's a little too slow for what I want. Okay, so what have we got left? Well, we wrote equals and compareTo in this motor class. Other than printing them out, how would we know that they work correctly for sure? What was that?
Test them.
Test them using a unit test. So if we have motor test here, so let's go show you how to stick in a couple of unit tests. There's lots of tests in there already. You can see what they are. We'll get down to the bottom and we'll add another unit test to get some practice. So here's a test. How about equals matches? And what I'll do is I'll make one motor. Steal the idea that I had before. So here's AA with a maximum of 20 hours. And here's motor looks like A. Sure, we'll write it like that. That's a new motor. Also with a serial number of AA. But this time we'll make it so that it differs somehow. And if we get the result of equals, which is a Boolean, true or false, so we'll make AA dot equals the looks like guy as a test, and we'll see whether or not it says they match. I think that matches should have a value of true to say they did match. Okay, so those are two very different motors, and let's just see whether or not they actually match. We'll run that unit test and equals matches. Just out of interest's sake, let me go and not write the equals by commenting it out and see what happens. So now we turn around, we run the test, and we say, did we find a match? And notice the unit test fails on that assert statement, and it says matches says false. The reason it says false is that if you don't write the equals, the default equals matches by identical, and these two are obviously not identical because new created new individuals. Okay. So now I'll go put that one back. So now you know equals work. Any other good test for equals? Not equals. So you also got to test the case. So I tested if things do match, I better be sure that it doesn't say they match all the time. I got to test don't match. So it becomes easier to write the second unit test. I've got too many of them in there. So you can write equals doesn't match. And in this case, I'll change this one to be something that's different, and instead of calling it looks like, I'll refactor, rename it to say doesn't look like. And now it should say false. So I chose one that was specifically different, and I'll even make it try to look the same. And it should say that they don't match. It should still be true. So there's all of our unit tests still passing for both equals, match, and doesn't match. Okay. Well, now let's do the sneaky one. How do I know that compareTo works? There's two different ways to test it. One way is to test them as individuals. I'm going to make A and B, and then I'm going to make sure that A is smaller than B, right? And then do the reverse. B should also be larger than A, which you could write in one test. That's testing them as individuals. Is there a way to test as a group? We actually did both cases in the driver, if you look at it. We started out by writing an individual test, which we could do again. This is basically a test, you know. Did one say it was bigger than the other? So there's the use of compareTo directly. What did we do here? Sorted them. So the other way that you could test is to make a list of 4 or 5 things, call sort to sort them, right? Make sure that you know that they were all jumbled up, and then they need to come out in a specific order, and then go through the list one at a time and go, I should get this one in this position, this one in this position, this one in this position, this one in this position. Either test will basically prove the same thing.
Is there a preferred one?
I don't care. Which one do you want to write? You could do both. Do you want to write the easy one or the hard one first? Let's do the list first, since it seems like it's a little more difficult. We'll go in and we'll make a test, and we'll see whether or not sort order so there's a test to see whether or not sort works. Okay. Well, we used a lot of this stuff from the driver. I wonder if I can just steal all of the motors I already made. So there's a bunch of motors. I'll stuff them into the motor test. And I've said that you know, these unit tests are basically small drivers. I guess I need all motors. So that's let's just go in our driver, and we'll grab all motors off the top. So here's our list of motors. We'll stuff that into the unit test. So I'm just borrowing stuff from what we basically already know. So there's my array list. Added them all to the list. I'll make sure that they're a little different. So there's, let's just put them in 3, 17, and 5. So they're definitely out of order, right? And then we'll call collections.sort on all motors. And notice it doesn't understand the word collections here. It says, I don't know what that thing is. And the option that you want is to do the import statement. We don't even see them anymore. The IDE will take care of that for you, and that'll just fix the import statement at the top. So it actually added a line in here, if you care to look, that said import that thing. I'm never going to ask you to write those on exams, because the IDE is basically doing it for you, and we don't care where they come from. But it has to be in there to make the compiler happy. Now, what true things can you say? That the smallest one should be in position 0, and the smallest one in this case is GG. Okay? The shortcut thing here is to say, I think that if I were to retrieve allmotors.get the number 0 item, it had better be whatever GG was holding on to. And the next one should be, which one? Get the number 1, it should be JJ. And the final one is got to be HH, and it should be number 2. Notice I didn't write a loop for that. The reason I didn't write a loop is because I can explain this to Mom really easily. Look, the first one should be this, the second one should be this, and the third one should be this, and the order that they come out should be that. Any way I could improve the words on this? How about if I use refactor, rename, and call this one, oops, not mess it up entirely, which I did. Let's just go back, double click on there, refactor, rename, and I'll call this one, don't ask me why I decided to do that, first, and I'm going to call this one second, and I'm going to call this one third. Okay? And so now when you're trying to explain this to Mom, you can go, hey Mom, I added these things in this order, the one I expected to come out first, then the third, and then the second, and oh, when after I've sorted them, if I go get them, they're now in that list in first, second, third, the order that I expected. So there's another quick trick, there's another one where the names help you go, oh, okay, I can see what's happening here. Okay, so lots of different ways to do it, but we're back to this name thing helps. Take it, save it, run it, and oh look, puts them in the right order so you know your compareTo works according to those numbers. Okay, and notice also that you can see by the names G, H, and J, which happen to be in alphabetical order there, that it can't possibly be sorting them by alphabetical order because of those names. It's got to be sorting them by hours, okay, which also helps. So taking those alphabetical order and also mixing them up differently helps people who see it to know which order to expect. Okay, and so there's another unit test. Done. Okay, so that's the first example of all the sorts of fancy things you can do with lists, using the equals versus index of, using compareTo for min, max, and sort. Tomorrow we'll do yet another example. We'll take hockey players and we'll do the same thing with a few more variations for hockey players to try it again.